Hi there, I'm Diego from SidecarTridge. It's been a while since I wanted to make a video explaining the basics of the new version of the multi-device. So here we are. Yep, this one. This is the new one. I thought it would be a great idea to make a longer video to walk you through the changes in the multi-device and share a bit of the story behind how it evolved. So I grabbed all the different versions I have built over time, and I brought it out of the lab to show you how things have changed. So let's dive in. Here are all the different versions I have built over time. Well, almost all of them. There is one that I just can't seem to find right now. But never mind. I will tell you all about it. Anyway, I think I have most of the important ones here. These versions in the middle, starting with the red one and evolving to this small one here, are the ones that actually made it to the store. These are the final and more polished versions that the people could buy. Up here you will see some smaller boards. These are prototypes. Some didn't work out, quite work out. Others helped pave the way for improvements, and just a few reached the dead end. But they were part of the journey. And down here, these large boards, all through hole boards, are the development boards I use for testing each version thoroughly. So yeah, let's get started. We will begin with the first generation development board. This was the very first development board I put together, and as you can see, it's pretty rough around the edges. There it is. Honestly, soldering this thing was not a joke. There were a lot of wires to deal with, but it allowed me to test with some really important things, like how the level shifters work, boosting the signals from 3.3 to 5 volts, or stepping down from 5 volts to 3.3. That's how I could connect stuff like the micro SD card or hook it directly to the cartridge board. So yeah, it was a true dev board, just for experimenting and testing. And here's something funny. At the beginning, I didn't even have a Raspberry Pi debug probe. I used this AliExpress Pi Pico clone instead. Yeah, the little guy right here. That plugged in and let me debug. With this setup, I wrote the first version of the ROM emulation software, and when I saw that it actually worked, and it worked with even this spaghetti mess of wires, and there weren't any signal impedance problems or issues. Well, sometimes a cable, a wire pop out. That's when I thought, okay, time to build the first proper version. This right here was the first real version I made, my first PCB, my first actual piece of hardware. And honestly, it turned out better than I expected. I designed it with just 2 layers, and a couple of versions later, I switched to 4 layers. And we will talk about that in a bit. It was a surprise for me, but this one worked really well. I used it for development for quite a while, and if you look closely, you will see that it's missing several things. For example, there is no power LED, there is no a proper power connection in the USB, and the UART connection is just hanging off the side here. But even with all that, it did the job. These buttons are the original ones, and the select button is up here at the top, and this is one of the first things that I end up changing, and you will see in the next versions. If you happen to have one of the red versions, you got one of the first 25 I ever made. I only handed these PCBs to people for testing. So there is now about 1,200, 300 out there units. These are the first 25, and they are super rare. I just give them away. This next one was the first version I made for the folks on the waiting list uh, when I first announced the project on Atari Forum and RetroWiki. If you take a look, it's basically the same board as the red one. I don't think even changed a single track. I think it's the same layout. The only difference is the color. I made it in black because, fun fact, black PCBs are cheaper to manufacture than the red ones. I had no idea at that time, but making red boards actually cost more and can be way more. So this was also the point where I started learning how to save on manufacturing cost. Both versions are lead-free, by the way. Also, that something that I figured out early on too. You cannot sell it in Europe with lead. So yeah, the difference here wasn't about the design. It was purely a matter of keeping the cost down while getting the project out to more people. This one right here was my first failed prototype. And why do I call it a failed prototype? Not because the electronics were wrong. It actually worked just fine in terms of functionality. The problem was mechanical. These connectors ended up way too close to the cartridge port. So if you imagine plugging this into a Mega ST or Mega ST, you will run into trouble. It just doesn't fit properly. That alone made it a no-go. Now, as you can see, it's a much smaller than the later trampoline style models. And honestly, there were a few things that I really like about this version. For one, the size. I still think this might had been the ideal form factor from the beginning. But by the time I got to these versions, a lot of people had already designed enclosures and 3D printed cases for the previous one. So changing the design suddenly would have created a bit of a headache. Another issue, the mounting holes, they were too small, which wasn't great for a mechanical point of view. They break easily, or they could break easily. But on the electronic side, there were some big upgrades. This was the first board I made using 4 layers instead of 2. The cost difference wasn't huge, and the boost in signal quality, both input and output, was totally worth it. Also, I moved the select button. Instead of pressing vertical from the top like in the early versions, it now presses horizontally from the front. That simple change helped about putting stress on the cartridge port, which was a win-win. So yeah, even though this prototype technically failed, it actually gave me a ton of insight for future designs. Now let's take a look at one of the development boards. At this stage, there were a bunch of things I wanted to experiment with, like routing signals differently, accessing more of the cartridge ports lines, handling more addresses, wider data buses, and so on. So I built this development board specifically to let me tinker with all of that. It also played a key role on the early testing of the very first versions of the DOS emulator. So this board wasn't just for the multi-device cartridge, it actually helped kick off development of the DOS emulator as well. It was a Swiss knife. It was a Swiss Army knife, sorry, for testing. Alright, so this board here was the first one to bring together all the improvements from the early prototypes, and it was also the first to use a 4-layer design. That change alone brought a pretty big boost in terms of electronic performance. One of the goals of this version was to make sure it could fit nicely into a proper enclosure, so you will notice the 4mm mounting holes that make it much easier to use it better. This version also introduced the little green power LED right here. A fun fact, in a very early batch, maybe a few of you out there had one, there was a small issue with the resistor for the LED. Basically, it was a bit off and the LED ended up shining way too bright. You should use sunglasses with the board. Still, this board worked great, and for a while it was the one that no, hold on, no, wait. Actually, this one was over here was the version that ended up being sold. Yeah, this one is the evolution of the early version. It's the same design, but now with the right LED resistor properly tuned. Electrically, they are identical, apart from this small fix, and mechanically, they are exactly the same. So no issues there. All right, let's check out another prototype. Well, actually, it's more a development board than a prototype. And this one might look familiar to some of you because I give it out to a few users, folks who were working on their own projects or contributing to development around the device. I built this board to experiment with powering external devices directly from the cartridge board. The idea was to create new external power lines that could safely deliver electricity without risking damage to the Atari ST. If you look closely, there is a little diode right here. It's there to block any incoming current from the outside. The key here is always to protect the Atari. If the Raspberry Pi Pico breaks, well, that's unfortunate, but no big deal. But the ST, no way. That's what we never want to damage. That said, the Raspberry Pi Pico is protected too. There is another protection stage built in before this. So yes, you can connect the Pico and the Atari ST at the same time with no risk. That diode ensures that nothing unwanted flows back into the system. I create separate circuits for each connector, each with its own fuse and diode for extra safety. This version is actually revision 2, as you can see. It's a through-hole board, and I went that route so I could easily connect probes, test signals, and throw it under the oscilloscope or logic analyzer without the hassle of dealing with tiny surface mount parts. And it worked great for that. It's really a handy board for development and testing, and I use it a lot. I still use it a lot. And this one right here is the board that led to what's probably the version that most of you have. I think I have made, I don't know, 500, 600. Honestly, I've lost count. This is version 2, or more precisely, version 2.3. And it's the first one where I felt like the device really had everything it needed. As always, it's built on a 4-layer PCB for better signal quality. Here you will see the dual USB connectors for powering external devices. It also has both GST connectors and traditional pin connectors as well, which made it super easy to run wires directly to external enclosures. So by this point, the design had really matured. Now, there is a little detail I want to show you. Not sure if you can see it on the camera, but underneath the Raspberry Pi Pico W, there is a copper-free window on the PCB. That's intentional. By leaving that area without copper, the Pico's antennas gets a much clearer signal. That small tweak actually gave us a noticeable better wireless performance compared to early versions. Also, you will notice that the Raspberry Pi Pico or WWH model plugs right into these headers here. And this brings us to two of the issues that we have dealing with up until now. First, you have to manually solder both headers and connectors you wanted to use the Pico directly. A bit of a hassle. Second, the infamous trampoline effect. You know, when you plug the board into the Atari and it sort of bounces or flexes. That's not great. So I started asking myself, what's next? What should the next evolution of this device look like? So the next step in the evolution was to explore different options for improving the board's design. I thought, all right, what can we do here? And one of my first goals was to shrink the size as much as possible. One of the ways to do that was by flipping the Pico W and soldering it on the other side of the board. That helped a lot with reducing the space. So I started prototyping new versions. And here we have two that are very similar. They are like siblings, small difference, but yeah, almost the same. If you take a closer look, one of them allows for a single external USB connector that carries both power and data. This is new. The other one is even smaller, with a more compact layout and connectors in place. But we have the same problem. And here's why. First, while I really like the design, it came with some pretty big challenges. The access to the data signals, I had to tap pads on the Raspberry Pi Pico, not the castellated pins on the sides. That means that you have to solder it using reflow soldering, not a classic solder iron. So this is definitely something that the average Joe cannot do. You need the pro equipment, and well, that was a no-no. Then came the cost. When I run the numbers to see how much it will take the manufacturer with reflow soldering at the manufacturing facility in China, the price basically doubled. So it didn't make any economic sense at all. And on top of that, I ran into another unexpected issue, the radio signal problem. The Wi-Fi signal from the Pico W dropped significantly. And why? Well, that's because the big metal connectors right here. It causes interferences, and it dropped the signal 20-25 decibels. So the signal strength was much weaker. So yeah, the law of physics had the final say, and that was no. That means that we need to keep a clear space around the Pico W antenna, and we have to try to work out that properly. So in the end, these two designs were super interesting, but they weren't feasible. So that led me to rethink the layout, and I find something in between. So the last version was something that allows soldering the Pico W on just one side, so no more Pico W flipping. We have to give up the USB data lines. We stuck with only power. We can have a clean copper-free window under the antenna for better signal quality. We avoid the trampoline effect thanks to the board's longer. We avoid the trampoline effect because it's shorter the size of the board, and most importantly, we can keep the cost in check, so it's affordable to produce. And that's how I ended up with the designs right here. This version, everything finally came together. Instead of having to rely on expensive soldering, everybody can solder the Pico W easily. The Wi-Fi signal is solid. There is no flexing or bouncing, and there is even outputs connectors needed if you want to debug things. Oh, and one last thing. I changed the output level shifters. And the reason why is because the AHCT technology consumes slightly more than the HCT chips. And is it important? Well, the fact is that every milliwatt that we can save with these old computers with sometimes very bad power supplies, it's worth it. So yeah, this version check all the boxes, and from here we have the new version 3 of the multi-device. This board is directly related to the prototype I just showed you, and there are a few cool things going on here. First off, we are using gold-plated connections, ENGI finish. It's not strictly necessary, but it does improve contact quality and overall durability, which is always a plus. Another thing I managed to include, thanks to the smaller size and a bit of cost optimization, is a 30-degree chamfer on the edge connector. I'm not sure if you can see it clearly. I will try to zoom in later, but it makes the board much easier to insert. Again, not essential, but definitely a nice touch. So with all these refinements, this became the third and final version of the SidecarTridge multi-device. It brings together everything I have learned over the past year or so, designing and building these boards. This version right here doesn't even use connectors. It's soldered straight onto the board. I soldered this using a reflow process, but honestly, any user can do it by hand using causing any trouble with solder iron. And if you do prefer connectors or header connectors, that's totally possible too. Here's one of my this is one of I use for development. Check this out. Look at the connector setup. Okay, I would like to show you something very cool. Maybe you cannot see at first glance, but this is a Pico W, not a Pico WH, and those three little pins over there, that's the debug interface. If you want to debug or work directly with the board, you just pop in a small connector right there, and let me see if I can show you better in this other board. And with these three pins, you are wiring the debug from the Pico W to that external JST, I can't remember if it's SH or XH connector. Yeah, so that small ones, that are for debugging. So what's the actual electronic difference between this board and this other one here on the left? Well, aside from the improvement I just mentioned, take a look at these little X marks. If you ever design PCBs and work with UART connections and you haven't crossed your TX and RX the wrong way, then honestly I think you have not really lived. Yeah, this one had the line swap. So that board was a bit of a flop. I end up handing those out to friends and at events as freebies. But this version, this is the real deal. This is the one currently available in the store. Fully refined, more compact, solid radio performance, easy to debug, and ready for whatever comes next. And that's it. That's the full journey of the SidecarTridge multi-device, at least up to now. Thank you very much for watching. See you in another video.